Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and nature topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover strength of materials in 6. The topic of this tutorial is a mixed bag of possible exam questions, round 1, question 2. The formulas used are included in the video after the question. The question is also posted in the description box below. Let's get straight into it. First things first, we need to know our question. And our question states, a parallel flange I section 406 by 178 by 74,8 kgs per meter is simply supported over a total length of 4 meters. The maximum allowable bending stress in the material is 118 megapascals and Young's modulus is 200 gigapascals. The deflection is limited to 11 millimeters. Now we've got to calculate. 2.1 says the maximum distributed load that can be supported, consider both limits. The actual stress and deflection due to the calculated distributed load, and then finally the force in a prop if it is placed in the middle of the beam and if it is 3 millimeters lower than the supports. Okay, first things first, we have to find, now our formulas go thus. M equals the stress, the bending stress, times Z. Now Z you will get on your tables, on your hot roll tables. Now this is only due to the XX axis. So look at only XX when doing these sums. Never look at YY, you only look at XX. Okay, now values to the left, values to the right. So 406 by 178 by 78,4. Sorry, 74,8. 74,8 kg per meter. Our length is 4 meters, and our bending stress, is 180 megapascals. Our Young's modulus, our E, Young's modulus is always dedicated as E, is 200 times 10 to the 9. And the deflection, now sometimes they will denote it as Y. Sometimes they'll denote your deflection as Y. But it's true, the true form of Y is delta, is capital delta, which equals 0,011 meters. Okay, first they want the maximum distributed load. So how we get this is by this. First we do M. So we need 180 times 10 to the 6 times 1329 times 10 to the minus 6, which is equal to, now let's put this in our calculator, 180 times 10 to the 6 times 1329 times 10 to the minus 6. Okay, I get 239, comma 22 times 10 to the 3 Newton meters. Okay, next step, we want to find the weight. So W is equal to 8m over L squared. So that's why we needed m. That is why we needed our m. Which was calculated there. So all we have to do now is say W is equal to 8 times 239,22 times 10 to the 3 all over 4 squared. Let's put that in our calculator. 8 times 239,22 times 10 to the 3 over 4 squared equals 119,61 kilonewton meters. Now these will be very important later on. So m equals 239,22 times 10 to the 3 and W equals 119,61 times 10 to the 3. Okay, now this W is taking into account stress. So the next W will be taking into account delta. So our next stress is taking into account our deflection. Z equals 1. Okay. I. The next one we'll need I. So this is IXX, which is 174,2 times 10 to the minus 6. Perfect. Now, W equals 384 EIY over 5L to the power 4. Now, our Z is XX and our I is XX. Now, these are both from your hot rolled tables. Now, when this question is presented, this entire question is mainly presented, remember that they will always have a question very similar to this. They'll have in essence, it's the same question, just different values. They'll normally change either the deflection, or they will change the bending stress. But in essence, it's mostly exactly the same. So, now we're going to do the weight taking into account deflection, which is what I've done here. This is how they write the formula, but the formula is really y is equal to delta, as I've put there. So if you understand that your deflection is delta, remember it can also be written as y. Okay, so let's go. 384 times 200 times 10 to the 9 times 174,2 times 10 to the minus 6 times 0,011 all over 5 times 4 to the power 4. let's put this into our calculator. Now, 384 times 200 times 10 to the 9 times 174, 2 times 10 to the minus 6 times 0,011 all over 5 times 4 to the power 4. Equals 114,972 kilonewton meters. Okay, so that is our weight considered with deflection only. So 114,972 times 10 to the 3. Okay, now they want the weight. Now they want just the weight. So what we're going to do is take our weight with regard to stress and minus it with the self-weight. This is the self-weight of our beam. So our self-weight is W is equal to 119,61 times 10 to the 3 minus 74,8 times 9,81. Now, to get it into newtons, to get kgs per meter into newtons, into newton meters, you have to multiply by gravitational acceleration. So 119,61 times 10 to the 3 minus 74,8 times 9,81, and we get our sum. Right, now this sum works out to W, and we're going to put another W here, 118,876 times 10 to the 3. So this is 118,876 times kilonewton meters. Right, next question. They wanted the actual stress. They want the actual stress in the beam and the actual deflection. So, how we do that is by saying the actual stress is equal to what they gave us right in the beginning. It's 180 megapascals. Now for the actual deflection, so I'm going to do this as delta, because that is how I was trained. So equals 5W L to the power 4 all over 384 times E I. That is our formula. So, next point is we'll go 5 times 119,61 times 10 to the 3 times 4 to the power 4 all over 384 times 200 times 10 to the 9 times I, which is 174,8 2 times 10 to the minus 6. Let's put that in our calculator. So we have 5 times 119,61 times 10 to the 3 times 4 to the power 4 times 384 times 200 times 10 to the 9 times 174,2 times 10 to the minus 6 equals. Our deflection, as you'll get, is 0,011 meters. So our deflection is 11 millimeters. That is our true deflection of this. So that is exactly with what we started with. So we know that this is the true deflection with that exact bending stress. So now finally, what we're going to do is they want the force in a prop that is placed in the middle of the beam if it is 3 millimeters lower than the supports. So, now, they want the force of this prop. So, deflection means it is going down. So, okay, next question. They want the force of the prop if it is placed in the middle of the beam, if it is 3 millimeters lower than the supports. Okay, so delta is equal to FL3 over 48 DI. Okay, so what we want to do is now we've got two deflections here. So 11 minus 3 times 10 to the minus 3 equals. Now, F we don't have, but we do have L, so that's 4 to the power 3 all over 48 times 200 times 10 to the 9 times 174,2 times 10 to the minus 6. Okay, so now what we need to do is a bit of formula manipulation. We want F. So these go to the top and that goes to the bottom. So 11 minus 3 is 7. 7 times 10 to the minus 3. Multiplied by 48 times 200 times 10 to the 9 times 174,2 times 10 to the minus 6 all over 4 to the power 3, which is all equal to F. Okay, so what we're going to do now is we are going to say, now, F equals. So let's go, overs and under, 7 times 10 to the minus 3 times 48 times 200 times 10 to the 9 times 174,2 10 to the minus 6 over 4 to the power 3. Okay, our total force is 18,000 2,91 kilonewtons, sorry. Just plain kilonewtons. And that is our final answer. Okay. Now, when you do these sums, please remember that if you ever get a hold of a memo, some of the memos are wrong. This particular sum, the memo was wrong with their I value. It was wrong with the I value. What I mean is, what they did was they changed 174,2 to 274,2. So if you look at your memo, also look at your hot roll tables. Look at your hot roll tables for the right answer, because the book is invariably, your textbook is invariably right, and the memo will probably be wrong. And then you'll find that you have wrong, then you'll find that everything will cascade. Everything will cascade because you have the wrong value. One wrong value can cascade this entire thing. So what do you need? That's what you need to realize. So always check your memo for errors. Always check your memo for errors. Never trust the memo. Always check it. So the memo is not gospel. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.